Hello, this is section 2.3 in the textbook. I want to do number 28. Right here, it says, use the squeeze theorem to show that this limit as x goes to 0 of the square root x cubed plus x squared times sine of pi over x is equal to 0, and illustrate by graphing the functions f, g, and h on the same screen. All right, so let's copy this over to some. Okay, here it is. So the first thing you have to do on all these squeeze theorem questions, especially ones where you're dealing with trigonometry, is you need to come up with an inequality. So you have to establish that f is less than or equal to g, which is less than or equal to h, where f, g, and h are functions. Okay, so whenever you have anything involving sine and cosine, the trick is to realize that sine of anything, let's say sine of theta. So sine of theta, by the nature of sine, is always in between -1 and +1. If you look at the graph of sine, it just goes up and down. It just bounces up and down between -1 and +1 forever, regardless of your angle. Okay, now so we've established that sine theta is always between -1 and +1. So then you can replace theta with pi over x, because that's just some angle. So sine of pi over x is always between -1 and +1, except when x equals 0. So let's make a comment there. X cannot be 0 because then you have undefined. And if undefined is not less or greater than 1, it's just undefined. But for all other values of x, sine of pi over x must be between -1 and +1. Okay, so there's the sine over x part right there. So next, I want to multiply everything by this term, and the square root x cubed plus x squared. By doing that, I'll have the square root times the sine in the middle, and I'll have two other functions on the outside. So let's just put this in parentheses and multiply everything by square root x cubed plus x squared. So one of those rules of inequalities, if you have a is less than b, then if you multiply both sides by something, then NA must be less than NB, as long as N is positive. If you multiply by negative, the sign switches. But in this case, we can just, we're talking about square roots. If you make a graph of the square root, we're dealing with the principal square root, so that's always going to be a positive number. So it's okay to safely just multiply everything by that square root expression. So then I get -1 times the square root becomes negative square root x cubed plus x squared must be less than or equal to square root x cubed plus x squared, which is times sine of pi over x, put that in parentheses, and which is less than or equal to 1 times the square root is square root x cubed plus x squared. Okay, so I've established my inequality, and that's step one. Any squeeze theorem situation, that's your step one. So this is like my f, this is like my g, and that's my h. Now notice that this g is this function g is exactly the same as the function that we're trying to prove that the limit as x goes to 0 of this. And so at this point, step 2 then is to show that f approaches 0 and h approaches 0. Okay, well that's just direct substitution here, because limit as x goes to 0 of negative square root x cubed plus x squared. As x goes to 0, x cubed goes to 0, x squared goes to 0. So all this is just going to 0. And same for the h. So limit as x goes to 0 of square root x cubed plus x squared also goes to 0, again by direct substitution. And so if, according to the squeeze theorem, we can move on to step 3. Let's pick another color for step 3. So then you can conclude that if a function g is in between two other functions, and we know that the f goes to 0, or whatever it is you're trying to prove, and h goes to 0, then we're forced to conclude that g must go to 0 as well. Okay, so conclude that the limit as x goes to 0 of that middle function, which was square root x cubed plus x squared times sine of pi over x. Okay, that also must equal 0. Okay, and that's it for this, using the squeeze theorem to prove that the limit goes to 0. But let's illustrate this graphically as well. I'll just go to desmos.com. Okay, so here's desmos.com. Click graphing calculator. So let's type in those three functions first of all. Okay, so type in. Okay, hold on. It's not. Okay, there it goes. Okay, y equals. Let's start with the square root function. Square root. You can do sqrt for short, and then it becomes a square root symbol. X to the third power plus x to the second power. Okay, so there's our first function. That's the that's like the h. All right, now press enter. Now let's graph also y equals negative square root of x cubed plus x squared. All right, so you can see it's just the mirror image. It's just flipped upside down. So there's negative square root of x cubed plus x squared. Okay, and then finally, the last one is involving sine. So y equals square roots of x cubed plus x squared, and then times, I'll hit the times symbol here, sine of pi, and I believe you can just write, just type pi for pi, divided by x, closing parentheses there. Okay, and enter. Okay, so we'll zoom in a moment, but you can see that the green curve is sine of pi over x times the square root x cubed plus x squared, and you can see it's always trapped in between the other two curves. So that visually illustrates what we established earlier on, that right here, that the function sine pi over x times the square root is in between those other two functions. Okay, so back to the graph. Let's zoom in a little bit here, and there we go. So you can see that sine of pi over x, because of the nature of sine, it's bouncing up and down, but it gets smaller and smaller and smaller, and you can see that sure enough, all three of these functions are heading towards 0 as x approaches 0. So that visually demonstrates the fact that these two squared functions go to 0, and then the conclusion that the function, the square root times the sine, goes to 0 as well. And that's it for that exercise.